All right, so today's class for algebraic problems, we're looking at coin problems and mixture problems. So let's take a look at our first one here. So again, diagrams are very helpful when working with these kinds of problems. So in this first example, two bags contains the same number of dimes as nickels. If the value of the coins in these bags is $2.85, how many nickels and how many dimes are there? So first of all, if we look at this diagram here, the first thing you'll notice is it's using whole numbers, not decimals. So 10 cents, 5 cents is shown as whole numbers, and then $2.85 is shown as 285 cents. And the reason why it's done this way, it's just easier to work with the whole numbers. But if you want to put it into decimals, you can, right? Like for 10 cents, you can show it as 0.10. For 5 cents, you can show it as 0.05. And for 285 cents, you would just show it as 2.85. All right, so let's take a look at this one here. So we know that there's two bags and there's an equal number of dimes as nickels. So the first bag is X, that's 10 cents, and plus X, which is 5 cents. The total is 285 cents. So to get our equation, it would look like this. So 10x plus 5x is equal to 285. Okay, so next we would multiply this out, so that just becomes 10x plus 5x equals 285. Combine the like terms, we get 15x equals 285. Just divide by 15 now, both sides. And we get our answer, x is equal to 19. Okay, so go back to our x's here in the diagram. This basically means that there are 19 dimes and 19 nickels. 19 dimes and 19 nickels. All right, example number 2. All right, so example number 2, a man has dimes and quarters worth $9.50. If he has 50 coins in all, how many dimes and how many quarters does he have? All right, so we've got our quarters, we have our dimes. We've called the quarters X. Therefore, because we're told there's 50 coins in all, our dimes we're going to call 50 minus X. Our total, again, we're using whole numbers. Instead of using $9.50, we're just using whole numbers, so it's 950 cents. All right, so our equation then, 25x plus 10 times 50 minus x is equal to 950. All right, so multiplying this out, we have 25x plus 10 times 50 here is 500 minus the 10 times minus x, so minus 10x equals 950. All right, next we would collect our like terms. So we get 25 minus 10, so that's 15x plus 500 equals 950. Next, we would subtract the 500, subtract 500, and we get 15x is equal to 450, and then divide by 15, and finally, we have solved for x, which is 30. All right, so we go back to our original expressions here for each coin. So therefore, there are 30 quarters. And for the dimes, it's 50 minus x, so 50 minus 30, which equals 20. So there's 20 dimes. Yeah. All right, so this next example, a bag contains 30 coins, all of which are either quarters or dimes. If the total value of the coins is $5.85, how many of each kind are there? So again, we're just going to use whole numbers here. So 25, 10, and then 585 for the total amount. All right, so setting up our equation now, we have 25 times the x plus the 10 cents multiplied by 30 minus x, and it equals to 585. All right, so just multiplying this out, we get 25x plus 300 minus 10x equals 585. Okay, collect like terms. So 25 minus 10, that leaves me with 15. X plus 300 equals 585. Next, we'll subtract the 300, both sides. That will leave me with 15x is equal to 285. And then we just got to divide by 15, both sides. And that gives me that x is equal to 19. All right, so go back to our original expressions here. We set x for quarters, so therefore there are 19 quarters. And then for dimes, we go 30 minus 19, which is 11. So therefore, there are 13 quarters and 11 dimes. All right, so next we're looking at mixture problems. So mixture problems, we're going to set them up very similarly to the coin problems. So again, using like a labeled diagram really helps with these kinds of problems. So let's look at our first example. A grocer needs 30 kilograms of mixed spices, which he wishes to sell for 35 cents per kilogram. How many kilograms of spices, which sell for 25 cents and 40 cents a kilogram respectively, must he use to get the desired mixture? All right, so our example here for a mixture problem, a grocer needs 30 kilos of mixed spices. He wants to sell it for 35 cents per kilo. How many kilograms of spices, which sell for 25 cents and 40 cents a kilo respectively, must he use to get the desired mixture? So we've set up our diagram here with everything we know from the question. So now we can go ahead and create our equation. So 40 times x plus the 25 times the 30 minus x is equal to 35 times 30. All right, so there's our equation. Now we can go ahead and solve for x. So first we'll multiply this out here. That gives me 40x plus 750 minus 25x is equal to 1050. All right, we'll collect our like terms here. 40 minus 25, which is 15x plus 750 is equal to 1050. We'll subtract 750 from both sides. That leaves me with 15x is equal to 300. And then we'll divide by 15 on both sides. And I get x is equal to 20. All right, and that's in kilograms. So if we go back here, he'll need 20 kilograms of the 40-cent spice, and for the 25-cent spice, we're going to take 30 minus 20, which is 10 kilograms. So you'll need 10 kilograms of the 25-cent spice. Okay, so our next example, we have a merchant mixes peanuts, which are worth $2.80 a kilo. We've just used 280 cents. And then we have cashews that are worth $3.60 a kilo, so 360 cents. And I've got the C there for cashews, P there for peanuts. And he wants to sell the mixture for $3.12 a kilo, so 312 cents. So we know here that he has 75 kilograms of peanuts. So we've put the 75 here. How many kilograms of cashews does he need? All right, so for cashews, it's X, and then the total will be X plus 75 to make that mixture. So our equation then, so we have 360 times X plus 280 is being multiplied by 75, and that's equal to 312 times X plus 75. Okay, so multiplying everything out here, so this gives me 360x plus 280 times 75, which is 21,000. Then here we end up with 312x plus 312 times 75, which is 23,400. All right, so let's collect like terms and solve for x. So let's subtract the 312 on both sides. Okay, that leaves me with 48x plus 21,000 is equal to 23,400. Then we'll subtract that 21,000. And we have 48x is equal to 2,400. And then we'll divide by 48. And we get x is equal to 50, which is kilograms. All right, so x was already set up here for cashews, so therefore we're answering our question, how many kilograms of cashews does he need? So he needs 50 kilograms of cashews. Okay, so I'll give you guys this one here to try. A wholesaler wishes to mix nuts worth $1.28 a kilo with nuts that are worth 96 cents a kilo in order to make a 160 kilogram mixture that will sell for $1.04 per kilo. How many kilograms of each kind must he use? All right, so we have to come up with our equation here next. So we'll have 128 times x plus the 96 times the 160 minus x, and it's equal to 104 times 160. All right, so we get here 128x plus 15,360 minus 96x, is equal to, just put that in the calculator, 104 times 16,640. All right, so next we would collect our like terms here. 128 minus 96. That gives me 32x plus 15,360 is equal to 16,640. Then we'll subtract this on both sides. And that gives me 32x is equal to 1,280. Then we'll divide by 32 and we get that x is equal to 40 kilograms. All right, so going back here to our original expressions, that means we need 40 kilos of the $1.28 spice. So he needs 40 kilograms of the $1.28. Sorry, I said spice, but it would be the nuts. And then 160 minus 40, which is 120, and 120 kilograms of the 96 cents on nuts.